Hello, Michael.
Hello, Sam. You got married recently.
hmm
Congratulations, by the way. Now, I assume you had a bachelorette party, or as I would call it here in the UK, a hen party. How much did you know about what was happening?
I knew we were having a party. I knew the location, like the general location, but I didn't know any of the details of what my bridal party had actually planned for me. I didn't want to know. I told them to surprise me.
Yeah, I had the same thing. I had a stag do or bachelor party and got blindfolded and bundled into a car. I had no idea what was going on. Well, in the same way that you and I didn't have much information as to what was going on within our respective bachelor and bachelorette parties, today we are exploring different levels of access to information within our organisations, although in this case it's to do with data protection. I'm Michael Bird.
I'm Sam Jarrell, and welcome to Technology Now from HPE.
Well, Sam, this is our second episode in our mini-series in collaboration with HPE Labs, celebrating 60 years of innovation.
That is right. Last time we looked into the practicalities of quantum computing and how you would integrate it into our current computing architecture. And of course, we will link to that episode in the show notes.
Yep, and this time we are exploring the world of confidential computing. Very interesting. A way to keep your data secure from threats both external and internal.
Ooh, sounds fascinating. So who are you interviewing today?
Well, today we'll be hearing from Dr. Nigel Edwards, Director of the Security Lab at HPE Labs. And as this is a new concept, the first thing I asked Nigel to do was to explain what exactly confidential computing is and what makes it distinct from regular styles of computing.
So confidential computing is the protection of data while it is being processed or being used. So it relies on certain capabilities that are available in modern processors. And this complements the encryption of data in transit and the encryption of data at rest to provide what I believe is the most secure environment for protecting sensitive data.
So traditional encryption methods already exist and they've served us pretty well. What problem is this solving?
This is solving the problem of a hostile or compromised insider. So it's really mostly relevant for enterprise use. So today, typically system administrators have access to all data on the systems that they are managing when that data is being processed. And the reason for this is when the data is being processed, even though it's hopefully encrypted when it's being stored, once it's loaded into system memory, that is in the clear. And therefore, anybody with sufficient privilege on that system will have full access to that data and can potentially, if they're a malicious actor, exfiltrate it.
Right, so what you're saying is that if either there was a malicious actor within your organization or if that person's login details were somehow compromised, then somebody could then access that data even though you think it's secure because it's sort of sat within your organization.
To actually use that data to do useful work, it has to be decrypted.
That's potentially when
a hostile actor could compromise it.
So are we saying that this would be used across a whole organization's infrastructure?
So I think it depends on the sensitivity of the data. If you have sensitive personal information for customers, medical data, financial data, maybe intellectual property as well, it's the best technology to protect that data.
So do you have any examples of where, if the principles around confidential computing are in place, actually a malicious attack wouldn't have happened?
I'm thinking about system administrators again. So most common attack vector would be a system administrator that unfortunately has fallen victim to a phishing attack, which has enabled a cyber criminal or nation state actor to gain their login credentials. But there have been instances of hostile insiders capturing data. The most famous was in 2013, where a contractor working at the NSA, Edward Snowden, obtained access to tens of thousands of documents which were classified and leaked those to the press, which led to the the compromise of certain operations by the Five Eyes Security Alliance and also US government activities.
And so he had access to information that he maybe shouldn't have had access to.
If we applied the principles of confidential computing, it would make it much, much harder, potentially impossible. So in confidential computing, paradigm has evolved around using virtual machines. When the data is loaded into the virtual machines, it's encrypted in system memory. It's only decrypted when it's loaded into the processor within the context of the virtual machine. So if your malicious system administrator tries to load that data into the processor, because they're not inside the virtual machine, they're just a sysadmin on the system logged in as root, all they're going to see is encrypted data. It'll look like random data then. We'll use a secret key to decrypt the data, so it's then available in clear to the legitimate processors that are allowed to access the data.
Okay, I'd love to talk about the inception of confidential computing. Where did the idea originally come from?
The idea of protected enclaves, protected execution environments has been around for a very, very long time, several decades, I would say. The two dominant data center processor vendors have had capabilities going back, I think, to the mid 2015, 2016, but they were following a different approach. And so it really wasn't taking off. And earlier this decade, that changed when the two major x86 vendors, still the dominant in the data center, adopted a common approach based around virtual machines. So now you can start to use this with a common set of abstractions.
What's been the influence of HPE Labs?
Back maybe 10 years or so ago, we were working on memory fabrics and memory-driven computing. The idea was that there would be massive amounts of data, which surely are seeing, and that this couldn't be processed in a single place. We would have to have distributed memory and distributed computation devices. And when you look inside a modern server chassis, that is indeed what is happening. So out of our memory-driven computing work and work on memory fabrics, when we looked at that, we realized, well, actually, when you have all these different components that are involved in processing the data, how do you know that nothing's gone wrong? How do you know they're all in a good state? How do you protect that data? So we started looking at what it would mean to secure a memory fabric. And then we became aware of other developments in other companies, because a lot of technology advances actually takes place by collaborating between multiple companies. This led to discussions with the industry around how you secure memory fabrics. And it led eventually to a protocol called SPDM. It stands for Security Protocol and Data Model. And this is the protocol in confidential computing which runs between CPUs and GPUs so that the two entities can authenticate each other, and the data passing between a confidential computing environment in a CPU and a confidential computing environment in a GPU is protected by authenticated encryption. Several HPE employees were named on the first author of SPDM, and I can trace our contribution to that right the way back to the work we were doing on the machine and memory-driven computing.
And we've continued to work on confidential computing protocols over the years, that's continued to evolve.
We continue to work within the community. We're collaborating today with our partner suppliers within the ecosystem. We're collaborating with the Confidential Computing Consortium, which is an industry consortium established to promote confidential computing in 2019.
So why are we talking about confidential computing now? Have there been technical advancements that have meant that this is now a significantly more viable technology to implement within our organizations?
So SPDM is relatively new. That's only been around for a few years. And actually, it's not even fully in silicon today. It's coming. There have been announcements from various vendors where SPDM is being deployed in silicon to enable this. The technology is still evolving, still maturing.
So what are the current limits of confidential computing? Is this something that only nation states today would be using, or is this something that we are likely to start to see as just the standard way that organizations protect data?
I don't think today there's an easy button for confidential computing. And there are services that need to be put in place. There's tooling that needs to be put in place to construct a confidential virtual machine, which we are working towards. This has to be done. We need a common set of tooling across different vendors, and we need common services, which is why we made our attestation service open source. If we can get that right, then I think in maybe 5 years or so, it will become a regulatory requirement for sensitive data to be protected by these technologies.
Similar to how there are regulatory requirements for handling the credit card information, like it all sort of form part of that.
It will form part of that, and if you're not using it, then you won't be in compliance with the regulations.
Do you foresee a world where this just becomes the standard way organizations just go about managing data?
We will get to the point where the default will be that this is turned on when you create virtual machines. And also applies to containers as well. Like, it's using the same underlying technology, but for deploying virtual machines or deploying container workloads, the confidential computing capability will just be turned on. And developers and system users, they won't even be aware it's turned on.
Are we at the stage where actually there isn't a particularly big resource overhead?
I think the good thing is that the encryption algorithm that's used for this is AES. And AES can be accelerated very efficiently by silicon. So today, when we've got the hardware acceleration in place, the overhead we're measuring is order of a few percent, 1-2% for most workloads, maybe 5%, sort of worst case. But you require the hardware acceleration, the capabilities in the silicon. I mentioned that SPDM is not fully in the silicon yet, so we're having to basically emulate that in software. So there you're seeing an overhead, therefore, of 10 to 20%. But that will go in the next generation of silicon. So in a couple of years' time, that will be back down to order of 1-2%, which is negligible. You won't notice it.
Okay, so what measures are put in place so people will trust a confidential computing environment?
The foundation of confidential computing is something called a trusted execution environment. When a trusted execution environment starts, the process enters a special state and measures that. That measurement is signed by a private key that's known only to the processor. That private key is certified by the vendor, and that measurement can be made available by the trusted execution environment to an external entity, enabling them to do two things. One is that very certification, silicon certification, gives you an assurance that that trusted execution environment is protected. It's protected by data encryption, and it's protected from system administrators manipulating the memory to compromise the workload. The second thing it gives you is a measurement. So that measurement can be passed to a service to verify that against an expected measurement. So you know that actually that trusted execution environment is running the expected code. Then the paradigm would be to provide that trusted execution environment with a key from which it could load that data into memory, decrypt it, and start to process it. So, for example, load the database into memory, decrypt the database, and start processing the data on it. Load the data and the AI model into memory, decrypt those, and start using it.
Got it. Nigel, thank you so much for your time. It's been a real pleasure chatting.
Thank you.
You know what, Sam? I love learning new terminology that I've never heard before. It's one of the best things about doing this podcast. I've never heard of confidential computing until I sat down and had this conversation with Nigel. Is it new to you? Have you heard of it before?
The term is new to me. I feel like the concept in an abstract way is not new. We touched on our own personal analogies of this idea, but it also makes me think of zero trust. It's kind of similar in that regard, but this was the first time I'd heard an extensive conversation around this.
Yeah, so the concept is that data is encrypted at rest and data is encrypted in transit. But where it's not encrypted is when that data is being processed, or often it isn't encrypted when that data is being processed. And that's where that data can be vulnerable. And there is particularly internal vulnerabilities. So if there is sysadmin that falls victim to a phishing attack, or if there's just somebody internally that has malicious intent, they can then potentially get access to that data that's being processed. It's interesting because it's not something that I've thought about. And I think one of the things Nigel said, this will be the default. This would basically become a regulatory requirement if you're handling that sort of data.
Yeah, it seems like it gets more and more difficult every single day to secure anything. We've had some episodes where we've even talked about quantum cryptography, right? It seems as though this is just like table stakes, though, is the assumption that you need to be like doing absolutely everything possible to protect your data, not just from like bad actors, but from yourself to some degree, because even your own people can be weak points in your infrastructure and in your organization.
You made the right point with zero trust. Like the thing with zero trust is you go for a trust no one and you provide access as and when it's needed. And it's sort of a similar concept to this of just because they're a sysadmin, just because they have elevated privileges, doesn't necessarily mean they need access to that data, because if they have access to it, then other people could have access to it. And really, it's about making sure that environment is as secure as possible. I love the phrase protected enclave. I think that summarizes it quite nicely.
I think so too. He was basically discussing sort of that very secure environment as the starting point for when you can actually get access to this data. But again, it goes back to the conversation of like, does everyone actually need to be within that enclave? His example felt very, very poignant of when an inside actor can take your whole organization down.
I would agree with you on that. It's quite a thoughtful point, isn't it? So the final thing I wanted to ask Nigel was how, well, confidential computing is intending to be developed alongside emerging forms of post-quantum cryptography. I mean, to some extent, they sort of contradict each other.
The fundamental encryption algorithm that's used in confidential computing is AES. So AES 256 is actually the standard algorithm that the American National Institute of Standards and Technology are advising and recommending for security against the quantum computer. Today, they are using algorithms which are thought to be vulnerable to a quantum computer, ECDSA, RSA. Those need to be changed to the newer PQC algorithms, in particular MLDSA. So future versions of silicon will switch to using MLDSA instead of RSA or ECDSA to sign measurements of trusted execution environments. So what will happen is that the paradigm is fundamentally secure. We will need to update some of the firmware to use PQC algorithms.
Okay, that brings us to the end of Technology Now for this week. Thank you to our guest, Dr. Nigel Edwards, and of course to our listeners, thank you so much for joining us.
And if you've enjoyed this episode, please do let us know, rate and review us wherever you listen to episodes. And if you want to get in contact with us, send us an email to technologynow@hpe.com, subject line...
Trusted Enclave?
Yeah, Trusted Enclave. And don't forget to subscribe so you can listen first every week. Technology Now is hosted by Sam Jarrell and myself, Michael Bird. This episode was produced by Harry Lampert and Izzy Clark, with production support from Alicia Kempson-Taylor, Becky Bird, Nicola Makumbi, Alyssa Mitri, and Janessa Ayosh. Our theme music was composed by Greg Hooper.
Our social editorial team is Rebecca Wissinger, Judy Ann Goldman, and Jacqueline Green. And our social media designers are Alejandra Garcia and Ambar Maldonado.
Technology Now is a Fresh Air production for Hewlett Packard Enterprise. We'll see you at the same time, the same place next week. Cheers.
Bye, y'all.